Hi students, it's Miss Vernon and I'm back today to talk and teach on lesson 5.3a, which is solving systems by elimination. We're going to be talking specifically about how do you solve systems of elimination, but also how do you recognize when you should solve by elimination or the elimination method. Now, typically, if an equation is written in what we call standard form, the elimination method is going to be an easier method for us to use. If you're wondering, well, Ms. Vernon, what is the standard form of an equation? A standard form of an equation would be like 2x plus 3y equals 8. This is standard form because the x and y values are both on the left side of the equal sign or the same side of the equal sign. If you recall, in graphing, we had to solve for y before we could graph it. And with substitution, we had to get a variable by itself in order to use substitution. So let's see, how do we use the method of elimination to make it easier? So the method of elimination essentially says, get the number or the coefficient, we call it, but we'll use the number in front of the x or y terms to be the same. And again, it doesn't matter if it's the x term or the y term, but as long as the number in front of the x or y term is the same but opposite. And you might go, what does that mean? Then when you add them together, it'll add to 0. So you get the number in front of the x or y term to be the same but opposite, then add the equations together. Now, as we go through the process, it's going to make more sense. And I'm going to write a list of the steps that we follow in the left-hand column. So in this first method, or in this first problem, I'm going to go ahead and take a look at the coefficients in front of the x and the y terms. So the coefficient in front of x is 2 and negative 4. The coefficient in front of the y term is 2 and 4. Now, I like in this problem to work with the term in front of the x because they're already the opposite signs. Notice the top one is positive and the bottom one is negative. But they're not the same number. But I know that 2 times 2 is 4. So what I'm going to do is I'm going to multiply the entire top equation by 2. And what that's going to allow for me to do is make the number in front of the x become a 4. So when I do this, I get 2 times 2x, which is 4x. I have 2 times 2y, which is 4y. And I have 2 times 8, which is 16. Notice the bottom equation, I don't need to do anything to. I'm going to leave it exactly as it's written. All right. And at this point, I'm going to check again. I'm going to say, hey, is the number in front of the x term the same number but the opposite sign? Notice the top is positive 4 and the bottom one is negative 4. Because this happened, I'm going to then add these two equations together. Now, the reason this is allowed is because I did the same thing to every term. So the problem's still the same. Now, when I go to add these up, 4x and negative 4x is 0. I've eliminated the x variable altogether. 4 plus 4 is 8y, and 16 plus negative 16 is 0. Notice that I no longer have an x variable, so I can now solve for the y variable by dividing both sides by 8, and I get y equals 0. This is great because I know that in my final answer, I need to have an x coordinate and a y coordinate. Well, I found the y coordinate. We're halfway there. Now, I do need to go back and finish figuring out, well, what is x going to be? Well, if I know the y, I can plug this 0 in for either of my x values and solve. So I'm going to go ahead and plug 0 in for x in the bottom equation. So again, I'm going to let y equal 0. I apologize. I'm going to let y equal 0. And so I have negative 4x plus 4 times 0 equals negative 16. Now again, recall, we found that y equaled 0. So I plugged in 0 for the y value. And again, I said that wrong the first time, so just keep tracking with me. Well, 4 times 0 is 0. So really, I have negative 4x equals negative 16. And dividing both sides by negative 4 gives me a final answer of x equaling 4. So now I have solved for my x value. My final answer, or my solution to this problem, is going to be 4, 0. All right, you guys did a great job with that. Let's just go off onto the side and list the process that we did. So step 1 of the process, we checked to see if the number in front of the x was the same but opposite. So we checked that the number or numbers in front of the variable, and again, it can be the x or the y variable, are the same but opposite. And what that means is you'd have a positive number and you'd have the same number, but it would be the negative number. If that didn't occur, we multiplied by a coefficient to make it happen. In this case, we multiplied by 2. If not, multiply to make it happen. Awesome. And then the third step was add the equations together. And the fourth step was solve for the variable. There should only be one variable in it right now. And then the fifth step was plug in the answer to find the other value. Remember, you should always be getting 2 answers when working with a system of equations. All right, let's go ahead and take a look at the next problem. So I'm just going to draw a little divider here so that we know this problem is all over here. All right, so in the next problem, again, I'm going to take a look at the numbers that are in front of both the x's as well as the numbers that are in front of the y's. Those are the variables that we want to have add to 0, which means they need to be the same number but the opposite sign. In this case, neither one of them are the same number, but the y's are already opposite. So I'm going to work with the y term. And there's an invisible 1 in front of this y. So I'm going to multiply the top equation by, what do you think? Yep, you guessed it. I'm going to multiply the top equation by 2. What that's going to do is it's going to give me 8x plus 2y equals 22. The bottom equation, I'm not going to do anything to because notice that it was already a minus 2y. And by not touching it, what happened was the numbers in front of the y term are now the same number, but the opposite sign. Next, I'm going to, so I've done step 1, I've done step 2, so we're on to step 3. We need to add the equations together. When I add these equations up, I get 11x. These add to 0 equals 44. 22 plus 22 is 44. Next, I divide both sides by 11 and x equals 4. Awesome. I found the x coordinate of my point. I do need to go back though and find the y coordinate as well. So I'm going to go back up into my problem, and it doesn't matter which equation I plug it into. I'm going to plug in 4 to the bottom equation for the x because x equaled 4. So I have 3 times 4 minus 2y equals 22. I need to solve this for y to finish the problem. 3 times 4 is 12. Notice this is our solving that we did right at the beginning of the year. Subtracting 12 from both sides. Again, this is like your Mr. T table. Negative 2y equals 10. And then dividing by negative 2. 10 divided by negative 2, y equals negative 5. Awesome. I found the other coordinate of my point, and I now have my final answer. My final answer for this problem is 4 comma negative 5. We followed the process, and it led us to the answer. All right, let's take a look at another one. Ooh, I'm excited about this one. As I look at the coefficients in front of the x, I see they're already the same number, but the opposite sign. So I'm ready to solve right off the bat. I get to skip the second step and jump to the third one. When I add these together, the x's add to 0. When I add the y's together, there's that invisible one showing up again. So we have 5y equals 11 plus negative 16 is negative 5. And then dividing both sides by 5 gives me y equals negative 1. Awesome. I found the y coordinate of my ordered pair. It was negative 1. Now I need to do the second part of it, which is plug it in. Again, it doesn't matter which equation I plug it into. So I'm going to plug it into the top one, and I need to solve for x. So I have 4x plus negative 1 equals 11. Notice that I just took out the y and I plugged in negative 1 for it. Now I'm going to solve this just like I would do any other solving. I'm going to add 1 to both sides. I get 4x equals 12. And divide both sides by 4, and I get x equals 3. There you have it, final answer, 3 comma negative 1. Now, sometimes when the lines are written in standard form and the coefficient is already there, we're good to go. But as you saw in the first two, once in a while, we do need to multiply one or sometimes even both of the equations by a number to get that coefficient to be the same but opposite. Let's take a look at another problem. So in the next problem, which variable do you think you would want to make be the same but opposite? You guessed it, I would choose to make the y variables the same but opposite because they're already opposite, and I can multiply the bottom equation by 2 and have them be the same number. So I'm going to multiply the bottom equation by 2. Notice on this one, I'm going to leave the top equation exactly as I saw it. Negative 2x plus 2y equals negative 8. But the bottom equation, I am going to multiply by 2. 2 times 3 is 6x. 2 times negative 1y is negative 2y. And 2 times 22 is 44. Next, I'm going to add. This is step 3 of our listed steps above. When I add these together, I get 4x. 2 plus negative 2 is 0, so these add to 0. And negative 8 plus 44 is 36. Next, I need to divide both sides by 4, and I get x equals 9. So far we found the x coordinate. The x coordinate was 9. But I can't stop there. I do need to solve for y. So I'm going to take that answer and plug it in and find the other answer. So I'm going to plug it into the top equation, which is negative 2 times 9 plus 2y equals negative 8. This is a Mr. T solving scenario. So I'm going to go ahead and solve for y. Negative 2 times 9 is negative 18. Then I need to add 18 to both sides. And last, I will need to, what do? Divide by 2. And when I do that, we get a final answer of y equals 5. Fantastic work. You guys are really starting to get this. Let's go on to the next page and take a look. I have 2 more for you to try on your own. So take a second and pause the video and give it a try. Let's see how it goes for you. All right, I'm back. Let's go ahead and take a look. In the first one, I see that the x's already have the same number but opposite sign. So when I go to add these equations together, they add to 0. 2 plus negative 1 is just 1y. This makes this problem very easy to work with. Negative 28 and 23 is negative 5. Wow, we already have our y coordinate for this problem. That was really fast. Let's go ahead and solve then for the x coordinate. So we have the y coordinate, it's negative 5, but we don't know what x is yet. So let's go back up and plug in negative 5 for the y. So we would have negative 6x plus 2 times negative 5 equals negative 28. Negative 6x plus, or you could say minus 10, equals negative 28. Add 10 to both sides. Again, we're just doing our balancing here. Negative 6x equals negative 18. Last, divide both sides by negative 6, and x equals 3. Did you get 3 comma negative 5? I hope so. That means you're really starting to get the hang of this. Let's take a look at the last problem for today's notes. In this problem, you should have recognized that these are the same, but they're not the opposite. So in this problem, we need to multiply by a negative 1. This can sometimes be a tricky factor to remember. I'm going to multiply the bottom equation by negative 1 because I know that sometimes that negative at the end can get to be a little bit tricky. So when I do this multiplying by the negative 1, notice that the top equation is going to stay the same, 2x plus 3y equals 6. The bottom equation is going to be negative 5x minus 3y equals positive 12. Now that we've done the multiplying, that was step 2, we're going to add these equations together. 2 plus negative 5 is negative 3x. Don't be afraid to type that into your calculator. Sometimes we need that reinforcement. 3y plus negative 3y is 0. That's our ultimate goal. And 6 plus 12 is 18. Next, divide both sides by negative 3. X equals negative 6. All right, we're making great progress. We found the x value. But we can't stop now. We need to go back and find the y value as well. I'm going to plug in x to the top equation. So I would have 2 times negative 6 plus 3y equals 6. 2 times negative 6 is negative 12. Add 12 to both sides. 3y equals 18. And then we divide both sides by 3, and we get y equals 6. All right, let's just double check, make sure we don't have any errors here. So when we solved for x, we got -6. When we plugged it back in, we got 2 times -6 plus 3y equals 6. 2 times -6 is positive 12. We added 12 to both sides, divided by 3, and there you have it. All right, let us know if you have any questions. Good luck on solving systems by elimination.